All right, let's have a look. Okay, a couple of these here. I'm going to just go through a couple quick ones, and then I'd like to let you kind of work on some stuff. Okay, so get questions answered, et cetera, et cetera. So let's have a quick look at. Oops. How about something like number 10? Yes. All right, what are we gonna do? Let's have a look. Suggestions. And there's not just one way to do this. There's multiple ways you can approach this that are probably about equally correct. But no matter how you do it, you want to be organized in your thinking. So what can we do? We're trying to solve for the variable, A in this case. Suggestions. There's a bunch of fractions there, right? So that's first thing we want to probably identify in this is we've got to deal with a lot of fractions. We talked about that, week before roundup. What did we always try to do when we have a bunch of fractions? We want to clear the fractions, right? But you got to be careful with that too. I'm not going to say that's a bad idea. If we wanted to do something like that, what could we maybe do here? Any ideas? This is a little bit different than the one we looked at before roundup. The one we looked at before roundup, remember, it didn't have anything being multiplied. It was just a bunch of terms. And then that was easy to take care of, right? All we had to do was multiply through by the least common denominator of all the denominators. But notice this time that I've got this 9/8 that's being multiplied by this quantity. Okay? So you can do it, but you just have to be a little careful. We want to throw out a number that we could multiply by. 8? 8 seems good. Okay, why 8?
Technically, you put it in the denominator and that whole deal.
Okay, it works. I'm going to translate that. I know what you're thinking. I know what you're saying. It's the least common multiple of 8, 2, 4, and 2, right? So it seems like it's going to work just like before. But there's something else going on here. We've got this 8 out in front that's being multiplied. So if I were to distribute this, and let's just do that once. We'll come back and maybe look at this both ways. But if I were to distribute this guy here. Whoa. Kinds of toys, huh? Okay, if I were going to distribute the 9/8, what would I get on the left side? The 4 is really just the same as a 4 over 1, right?
Yeah.
Okay. So if I distribute the 9/8 to the 4 over 1, what am I going to get? I'm going to get 36 over 8. Okay, that's good. We can do that. Is that going to reduce?
Yeah.
Yeah, it will. What's that going to reduce to?
4.
What's a number, the biggest number that would go into both? 4 would want, right? Okay, so 4 is going to go into both of those, so I could divide the top by 4 and get 9, right? Bottom by 4 and get 2, right? Okay, could we maybe have gotten there a little quicker rather than multiplying straight across? What could we maybe have done?
Cross cases.
Could have canceled, couldn't we? Could have said the 4 over the 8 is going to become a 1 over a 2 and just gotten right to the 9/2. Either way. Continuing on, if I distribute the 9/8 over here, what am I going to get? Minus 9/16 and then times A, right? Equals, what about over here if I distribute the 3? 3/4. Good, 15, because that's like 3 over 1, right? So if I distribute over to there, I'm going to get, oh, and there's an A there, isn't there? 15 over 2. Okay. Now, this looks more like the problem we had prior to roundup. So based on this problem, if I want to clear all those fractions, what am I going to multiply by? 16, right? 16 is the least common multiple of all the denominators. So this time we could multiply through by 16. And now we can do that little trick, can't we? So let's see, I want to go. Oh, okay, so let's do our little trick. We know this time that we've got just a bunch of terms that are fractional. This time when I distribute the 16 through, the 16 is guaranteed to cancel all the denominators, right? We handpicked that number because all the denominators divide into it. So now we can do that little trick where we know we're going to be able to cross-cancel every time. Reduce first and then multiply. So what are we going to get here if we reduce? 16 over 2 is 8 times 9. 72. Good. Easier to reduce first, isn't it? It's a lot harder. 16 times 9, that's not, we don't want to do that, right? If we can avoid it. We'd rather reduce first and then multiply, so we're dealing with smaller numbers. What about here? 16 over 16? So we get minus 9a. 16 over 4. Remember this trick? 4 times 3, 12. 16 over 2. 8. 8 times 15. 120. Okay, and now we can solve that pretty easily, can't we? Right? So now we would just, we're going to push the variables to which side?
The left side, the right side.
Okay, I've heard left and right. Which one? What do we think?
Right side.
Right side, how come?
Because positive number.
You want a positive number. Good, so we'll add 9a to both sides. So we'll cancel the variables from the left, so where do we want to push the numbers? To the left. And so we end up with 12a plus 9a. And then over here, 72 minus 120. What's that? 48. 48. Sounds good. Negative 48. Yeah, good. Okay. Make sense? Last step. Good. And so if we reduce that, what goes into both those? 2 doesn't go into both. What does now?
I know it's 6 and 3, so it's
Well, look at the factors of 21. I mean, we don't really need to look for anything too big, do we? There's 2 things I want to remind you about here. So first question is, how do we know a 3 goes into those? What's the number trick to know if a number is divisible by 3?
Add together and see if they're divisible by 3.
Okay, add the digits together, and if the result that you get is divisible by 3, then the number is divisible by 3. So 4 plus 12 is divisible by 3, so 48 is. Now you can do, this doesn't come up very often, but you know that you can do that repeatedly, right? Like if we had a really big number, like let's say 9, 8, let's see, what's that going to be? What's that add up to? Somebody add that up real quick. You guys are smart. What's that add up to?
9876.
If I add those digits up, what do I get?
49.
49?
That's like a 17 and a 7 is a 24.
Ian says 48.
48?
That's what Ian says.
Okay, I'll buy it. 48, okay. So if I add all those up, I get 48, but what if the number were really big? What if it were just an enormous number? And so you get back, when you add the digits, still a number that's pretty big. What do you do?
Again.
Add them again.
Oh,
4 plus 8
12.
is 12, and now it's easy, right?
12, that's
So you
what
can keep repeating that process.
Yeah.
All right, so let's go back to this original one, though. So the suggestion was to multiply by 8. I still think that's not a bad idea. Multiplying by 8 is really okay here. It's, instead of distributing the fraction, which is fine, that worked great, no problem with it, but here's just another approach. We could also have multiplied by 8 to get rid of that fraction in the first denominator, right? So if we multiply both sides by 8, that's just going to cancel that 8 out, and it's gone, right? And on the left side, all I have to do is distribute a 9 now, which is better. So if I distribute the 9, what am I going to get? 36 minus, well, what's 9 times 1/2? Okay, but we don't want to do mixed numbers ever. We're done with mixed numbers for the rest of your life. You're never going to do mixed numbers. Now we just want improper fractions.
Would you have started by multiplying by 16 instead of by 8?
I mean, you could. Well, then maybe we'll take one last quick look at this and say, what if you, but sometimes it's hard to see that. Sometimes that number can be, hold that question until afterwards. It's a good idea. But what if we're just going to get rid of this fraction? And what's ugly about this? We're distributing something that is a fraction. Over here, we're distributing something that's not a fraction, so it's no big deal, right? But when you distribute a fraction, it makes things a little bit tougher. So one thing we could do is say, well, let's just get rid of the denominator from the first one, multiply both sides by 8. Once again, we canceled the 8s. What's 9 times 1/2? 9 halves. And over here, if I multiply 8, 8 times 3 is just 24 times 1/4 A plus 5 halves. And now I can just distribute the 24, right? And what do I get? 24 over 4? 6 plus 24 over 2 is 12 times 5, 60. Okay, so what was the good of that? Well, that's not too bad. What's the only thing I have left to do to get rid of the fractions this time? Multiply by 2, right? If I just distributed 2 through both sides, what do we get? 2 cancels, right? So 9A equals, okay, I bet that looks pretty familiar.
Oh,
Right? Go right back there. Do you see that? It's kind of a subtle point, but you see what I'm trying to demonstrate here? You gotta just be a little bit careful about this. Really, there's 2 pretty good ways you can look at this. You could either just power through distributing the fractions, like we did the first time, or you could clear the fractions in 2 steps. You could clear this fraction that's in the coefficients being multiplied, distribute integers, which is a lot easier to do, and then re-clear the fractions again, right at the end. Okay? Suggestion was made, well, why couldn't you be really tricky and just multiply both sides by 16? And the only way you could do that is if you looked ahead and said, okay, well, if I were to distribute, I would end up with a 16 on the bottom there and an 8 on the bottom there. And it gets a little bit, I mean, once you've done this a little bit and you're getting pretty darn good at algebra, then maybe you can look a step ahead and just kind of, all you're really doing is just saying, if I were to distribute, I don't want to go through the hassle of doing that, but if I were to distribute the fractions, what would be the magic number I would multiply by? And you'd have to kind of look ahead and see that it's a 16, right? And then that would make it a little easier. And then if we were going to, if we were just going to distribute at the beginning, instead of multiplying by 8, if we multiplied by 16, it would have made it a little bit easier. That's a little trickier to do, though. Okay? Questions on that? Okay, give me a 1 to 5. I'll do this a lot. So 5 meaning the scale. Okay, that's, you can make it kind of subtle. You don't have to advertise for everybody, but 1 would be, I need some more help on that. 5 meaning still pretty good, but we just did it. It can be subtle. All right. Okay, all right, okay. Okay, that's good, thank you. Okay, so how about, while we're at it here, let's look at number 11. Is there a question on one in particular?
Wait, on the homework, right?
Well, we can do, that's fine, we can do homework.
Okay.
13 and 8,
And number 5.
okay. Oh, I like 13, I think I like. Let's do. Let's see.
I had something like that, but I couldn't remember.
There we go. Yeah, let's do 13. 13's a good one.
Can we do 5 after that?
Sure. You betcha.
This is due tomorrow, right?
Yes, tomorrow. Okay, let's have a look. Everybody attention up here, please. All right, so if we're going to solve this, remember and it's been over a week, but we talked about when we isolate variables, where that's really all we're doing when we solve for a variable. If we start with our order of operations tree, remember we're always going to, first we're going to simplify, so we'll do regular stuff first, combine like terms and all that stuff. And then once we're down to a point where we have a single variable that we can point to, then we'll isolate it by reversing order of operations. Right, so we'll simplify things first. In this case, what's my variable? W. So when I've got a single W to point at, then I can always isolate that by just going backwards the order of operations, right? So what does that amount to then? What's the first thing I've got to do here? Say it again. Distribute a -3. Okay, so if we're working down order of operations, there's nothing to do in parentheses, no exponents, but there is some multiplication, right? So I've got to distribute the -3, and while we're at it, what else am I distributing? 4, okay? So that's going to give me -8, what? Help me out here. Minus 3W, minus, I heard it, 39, right? On the other side, we're going to get 4W plus 44 minus 7W. Okay, now what?
Combine like terms.
Combine like terms. So over here, I'm going to get a negative 3W, and then -8 plus -39 is what? -47, okay? Over here, 4W minus 7W is -3W plus 44. Okay, what's the problem here?
We got 0.
Yeah, so if we're going to continue to combine like terms, which side are you going to push the variables to? I mean, neither one is going to work, is it? If we add 3W to both sides, the 3Ws, the -3Ws are just going to cancel, right? And so we end up with the result, -47 equals 44. Now, what in the world, how do we interpret that? No solution, yeah. So we'll talk more about this when we get into the next unit. We'll look at this in much more depth, but for now, let's just establish a rule. If we're solving an equation and we end up with an answer where the variables disappear, there's 2 things that could happen. If we get an untrue statement, here's how you can think about this. How often is that statement true?
Never.
Never. So there's no solution, right? There's never a value of the variable that's going to make this work. And so there's no solution to that one. Okay. How about number 5 was asked about? While we're at it. Let's look at another one here too. How about this? We'll get right on to number 5. Real quick, how about this guy? What if we have something like 40 minus 8x equals negative 8 times the quantity x minus 5? It's on the in-class practice, it's number 12. So the white sheet, number 12. Okay, same kind of thing, right? I'm going to simplify first. What am I going to do first, obviously, here? The right side, distribute. So we get 40 minus 8x equals negative 8x plus 40. Now, same kind of thing's happening with my variables, right? If I add 8x to both sides, they just cancel, and then look what I end up with. 40 equals 40. Okay, how often is that true?
Every time.
Always. So if that's always true, what do you think the solution must be? Infinite solutions. Infinite solutions. Yeah, x could be anything, right? So a lot of times we'll talk about this. If the answer doesn't include a variable, we know that it's insensitive to the variable. It doesn't matter what the variable is. In both cases, it makes no difference. This example, it doesn't matter what the variable was, it's never going to work. In this example, it doesn't matter what the variable is, it's always going to work. So we would say all reals. A couple ways we could say this. Kind of using our new math symbols, we'd say something like that. X is an element of the reals. When you put this into Moodle, I'm just going to have you enter, it's like a double, I'm just going to show it to you. Because this will come up for sure. So it's a capital R for all reals, but it's not really an R. It's kind of a special R. So. Okay, so here's, like in Moodle, how would you do this? If this is your Moodle assignment, let's say, if I want to enter something that means all reals, look what it tells you to do. It says enter that weird-looking double-struck R. Where you get that is if you go into the symbol menu in Moodle. It's that guy right there.
Oh.
Okay? If it's no solution, you just enter a regular capital N. That's normal. But if it means all real numbers, you enter that. That represents a set of all real
You
numbers.
forgot, when you typed in no solution, would it be wrong?
It would. I mean, I would give you credit for it, but it would mark you wrong. Yeah. Okay, number 5. There's a question on number 5. Okay, so this is kind of like that first one we looked at. What are our options here? We've got lots of fractions, so this is ugly. Right, don't panic. We can deal with fractions. What's one thing we could do here?
What front side?
We could multiply by 9, right? Multiply by 9 to get rid of this one. Okay. While we're at it, we also probably want to get rid of, well, maybe we don't. We can just multiply by 9 because this is an uglier 9 than that is a 4, right? Because this is being multiplied by something. The fact that we have a fraction here might be okay. We're going to end up with some fractions anyway. But you see that there's kind of a red flag. This is a red flag right there, right? We know that if we're multiplying a fraction by a quantity, I'm either gonna have to distribute that fraction all the way through and do lots of fractional multiplication, which is fine. You know, we did it that way and it worked fine. Or we could just try to get rid of that 9 and make things a little simpler that way. So let's try that. If we multiply both sides through by 9. So it's gonna cancel that 9, that's good. And now when I distribute, what am I gonna get? So I've got this 4 that's left over. But before we do that, does that part make sense to everybody? Right? Okay. So if we distribute the 4 through, what's 4 times 3/8 going to be? See if you can simplify that for me too. 12/8 would be 6/4, which would be 3/2. So the first one we're going to get is 3/2 x. If I distribute the 4 over here, well, 4 over 16, that's going to just reduce to what? 1 over 4, good. So we get a 4 on the bottom, so just minus 27 over 4. Does that make sense? Okay. On the other side, I've got 13 times 9, so that's 90 plus 27, right? That's how you guys do that in your head, I'm assuming. And so 117 over 4. That's a lot easier, right? Now this is the easy kind of fractional problem where we're no longer multiplying stuff. So now we can clear the fractions by just multiplying everything through by 4. Okay. So 4 over 2 is
I mean,
2. 2 times 3, 6x. 4 over 4 is, all right, 1 obviously, times 27. 4 over 4 is 1 times 117, and now it's easy. Right, from there it's no big deal. Now we just, what are the 2 steps in order to get x by itself?
plus 27.
Add 27 and then divide by 6. Good. So let's try to do this. Let's wrap those up into one answer then. So what am I going to get? I'm going to get 117 plus 27, which is 144 over 6, and that goes in. Yeah, 24. Okay.
You got it wrong, man.
Okay, make sense?
Hey, your son got it wrong.
Uh-oh. Okay. Okay, what if you see something like, any other questions? Okay, how about something like this? What if you have, what about something like that? So if I have a fraction equal to a fraction, where I've got variables in there, what do we call that?
Fraction.
A fraction equals a fraction, there's a special name we give to that kind of an equation. What is that?
Proportion.
Proportion. Yeah, that's proportion. Right, now that's different than if I had something like 7/3 plus 3, that messes it up. That's not a proportion, right? Because now it's just not a fraction equals a fraction, it's a fraction equals a fraction plus some other stuff, right? That wouldn't work. But what do we always do? There's a really easy trick when we're solving proportions. What do we always do? Cross multiply. Cross multiply. So we're going to multiply, or we're going to set that cross product equal to that cross product, right? So what's the green cross product going to be? I'm multiplying 3x minus 9 times 7. How would I write that?
Probably distribute.
I'm going to distribute. I will, but before I distribute, what would I write?
7 on the side.
7 times the quantity.
Minus 9.
Good. Equals, what about the red cross product?
Red cross. 3 times 25x plus 6.
Yeah, that sounds good. That sounded more like a mathematician like that. So now if I distribute, this is no big deal. Now it's a piece of cake. I can distribute the 7 on the left side, distribute the 3 on the right side, and then it's easy, right? Okay? Questions? As far as good? Okay. It is, you're right. Okay, I'm gonna let you work. Why don't you grab a Chromebook if you don't have one? You can get questions answered. I did put up, so what did I put up? I put up I added a third assignment to the evaluating section. So that's up there available, and I'm gonna add real quickly, it's not at this very second, but I'll put it up right now. I'm gonna put up 2 short assignments on solving multi-step equations. That's it, yep.
We only have 2 minutes left.
So why don't you guys just relax, take it easy.